Hello, everyone. I'm Jim Garrison, and I want to welcome you to this session of Humanity Rising as we convene our second of three programs on how we deal creatively with climate change. As we begin today, I just want to note that this is the 700th session of Humanity Rising. And it marks really an extraordinary milestone when you think of it, 700 sessions since May of 2020, as we convened back then in the depths of the pandemic with everybody in lockdown and engaging in mask wearing and social distancing, and everyone was being motivated to fear for their health and the human future. We thought at Ubiquity University that what we could do was just simply convene a free Zoom call every day. So no matter where anybody was around the world, they could tune in and they could get interesting information. And more fundamentally, come together as community at a moment when all of us were being forced essentially into martial law and into isolation from one another. And little did we know that this was going to create a tsunami of attention. Before we knew it, we had people in over 130 countries registering to watch our programs. We had hundreds of organizations, over 350 organizations that came to us and wanted to co-sponsor in some way. We started to broadcast through live streaming partners, and 700 sessions later, here we are. And I just want to express very deeply my gratitude for all of you out there in our global audience, all the partners that have showed up, all the speakers. We've had over 2,000 speakers, the different initiatives that we have convened, because the essential mission of Humanity Rising has been on how do we transform conversations that matter into actions that make a difference. Every program is something that matters to our world. And we bring in people like we're going to hear today, who are both extraordinarily knowledgeable, but also deeply compassionate about the suffering of humanity in our present state as we teeter on the precipice of self-destruction, and are passionately 24/7, 365 working as creatively as they can to ensure, in a way that we can't even imagine right now, because things look pretty bleak, that we can ensure not only human survival, but ensure that survival by realigning humanity back into what and who we most essentially are. And that is children of the earth. The great mission of our time is to harmonize human endeavor with natural systems. And we speak about this at a time when, just yesterday, the World Meteorological Organization announced that sometime in the next 5 years, global temperatures are going to exceed 1.5 degrees centigrade over pre-industrial levels. Scientists have been warning us for decades that if global temperatures exceed a 1.5 centigrade degree rise over global pre-industrial levels, that the global ecology will fracture in a way that is almost certainly irredeemable. And for the first time, one of the years coming up will exceed the 1.5 rise. And so we need to take that in. They're also predicting that the next 5 years, cumulatively, will be the hottest years in human history. And what are we doing? We're waging war between the superpowers as the United States takes on Russia and Ukraine, and the United States takes on China around Taiwan. Rather than dealing with the most obvious challenge in the world, that we have to radically realign such that we increase biodiversity globally in a very short period of time to preserve human life on planet Earth. We're waging war. And the climate issue is essentially off the table. That's a measure of our predicament. Even the news clip about the fact that we're going to exceed 1.5 degree rise was a blip. It went up for a little bit yesterday. I couldn't find it in the news this morning, and I had to Google it. That's how out of touch our world media, our politicians, our global corporations, and the public are, and is the reason why we're teetering on the brink of self-destruction. So the motive of Humanity Rising, day by day by day, is to help wake people up to the magnitude of the crises, the multiple crises, the multiple code reds that we collectively face. And in the world in which we have to be aware that our governments aren't going to do anything to solve the problem, but prefer to arrange deck chairs on the Titanic, we, the people, have to somehow come together and enable humanity to rise. The challenge before all of us is immense. And we need to internalize that as graciously as we can, not get paralyzed, but to reach out in a spirit of radical collaboration so that we can do what is necessary now in a matter of just a few years. We no longer have decades. And what the World Meteorological Organization is saying is we're there. And if we push through that 1.5 centigrade rise over pre-industrial levels, essentially our ecology is going to spin out of control in a almost unimaginable way. We can see it all around us already. Ecological turbulence is tearing the world apart, shattering human infrastructures all over the world. And we prefer going to war. It's a level of deranged madness that maybe is unprecedented in human history, that our instincts for survival are that tarnished and eroded that we've forgotten even how to save ourselves from ourselves. And that's why we broadcast Humanity Rising day after day after day with people like you're going to hear in this session, who are speaking truth to power in every way that they possibly can. So thank you for joining us, everyone. Welcome to Humanity Rising as we commemorate our 700th session. And before we dive in to our subject for today, let us just simply breathe together. So in a moment, you're going to hear the sound of a bell. When you hear the bell, just breathe in slowly for about 5.5 seconds. You'll hear the sound of another bell and breathe out for 5.5 seconds. We're going to take 10 breaths together, consciously and coherently, and then we'll begin our program. Thank you, everyone. Welcome to Humanity Rising. you, everyone. Sorry for the glitches in our breathing. Sometimes Zoom happens. In fact, it happens on a regular basis. You have no idea what goes on behind the scenes as we get people together for our broadcast. Technology, it can be utopian and then dystopian in the blink of an eye. So thank everyone for their patience as we appreciate actually the miracle of Zoom technology that allows people from all over the world for free to communicate. It's really an extraordinary thing. So when these little glitches happen, we try to just take them in our stride. And now it's my great pleasure to bring on my good friend, Rob DeLate, who's convened this 3-day program on cooling the climate chaos out there. And so Rob, thank you for everything that you are doing. Rob is coming in from Bali, actually. So he's in the Pacific. And our other speakers coming in from the UK. I'm in Northern California. Our tech guy's in Berlin. And Stan is in Philadelphia. So that just gives you a measure of what technology can do as we convene our global broadcast. But Rob, thank you so much. And I turn the program over to you.
Well, thank you, Jim. Thank you so much. And congratulations with this incredible effort and 700 episodes of Humanity Rising. You're doing a great service with your team for humanity. And we have to push on because we need action. We need global action. We need basically a movement of the people rising because, as you said, governments will not do it. It's up to us to change the whole thing. And today, I'm very grateful that you gave us the possibility and time to present the Cooling Climate Chaos project, which says as a subtitle, The Practical Path Out of the Polycrisis. And basically, that's what we are presenting based on theory developed by James Lovelock and one of his close associates, Peter Bunyard, and another group of people around them. Based on the Gaia theory, we actually think we have enough evidence to show that we can reverse the climate chaos, extreme weather, and the damage much faster than is realized right now. So because of a technical glitch, Peter Bunyard, who was going to speak yesterday about the theory behind it, had to relinquish and will do it today because his audio is in order now. Yesterday, we basically talked about regeneration. How do you regenerate your planet, which is not a small thing to do for sure. But Peter has the in-depth knowledge about the way climate works and how we can apply that to the possibility of regeneration of the planet. Peter is an emeritus professor, 83 years now, and has been in retirement for some time, but is kind enough actually to join us to explain the Gaia theory and what it means actually for understanding our living planet and how the planet can actually be regenerated much faster than people think. So with that, I'll give the floor to Professor Peter Bunyard, and it's an honor to have you here, Peter. Thank you.
Thank you very much, Rob. And it's wonderful to hear about the 700 sessions that Humanity Rising has had. This is all news to me, and it's wonderful work that obviously is being carried out. Right, I'm going to show a presentation. Share. Right, and let's put that up there. Right, so hopefully you can all see that. And here we're going to talk about Gaia a little bit, and also in particular about the biotic pump and how the biotic pump, which is very much part of Gaia, can help us solve some of our problems. Okay, well, the first thing to realize, and it's an extraordinary thing really, is that the climate which we enjoy and which is currently affecting us all is actually the result of life's interaction with the planet, with the Earth's surface and the atmosphere of all that time ago, over at least the last 3.5 billion years. And in fact, when we think about the gases in the climate of today, nitrogen at 98%, that is there because of life. It's not there because if life had not been on this planet, we would not have nitrogen in the atmosphere. It would have all been oxidized and it would not be in the atmosphere. If we think of the oxygen, as we all know, has come from vegetation. It's come from photosynthesis. It's come from, originally from cyanobacteria, dating back well over 3 billion years. And those same bacteria have now, through what's known as endosymbiosis, have come into all the leaves of vegetation, carrying out that activity of photosynthesis, drawing down carbon dioxide, turning it into carbohydrates, and therefore providing the energy for all life, including ourselves. In the photo at the right, at the top of the screen is James Lovelock with another wonderful, wonderful Gaian biologist, Lynn Margulis. And really the two of them together formulated what we basically now know about the Gaia hypothesis. And the consequences of Gaia are simply extraordinary. If we had oceans but no life, the oceans by now would be so salty that they would be as dead as the Dead Sea. But in fact, life has managed to, through calcareous deposits in the ocean, has managed to seal off parts of the sea, and the salt water then evaporates, leaving a salt pan behind. And tectonics, the actual movement of the plates, which form mountains, then takes over and takes those evaporite basins full of salt way up in high altitude into limestone mountains. And in fact, Lake Titicaca is basically a fraction of the sea, which was so isolated in this way by the deposition of calcium, of calcareous deposits from life, that it's now up at what, I don't know, 13,000 feet, something like that. So the other thing which is very important to realize for us and for life in general is that because of the production of oxygen, and we now have 22% oxygen in the atmosphere, that oxygen percolates upwards from the surface and gets into the stratosphere. And in the stratosphere, the sunlight, of course, is very strong, and more than 12 kilometers up from the surface of the Earth. And the oxygen splits into two single atoms, it's monatomic atoms, because it's split by the most powerful of the ultraviolet light, which is ultraviolet C. And ozone is formed from that. And the ozone then interacts with ultraviolet B and converts back into oxygen and so on. And in fact, that process prevents these very dangerous ultraviolet rays from getting down to the Earth's surface, where they would make life pretty impossible. Right, and the other thing about the evolution, that of life with the planet is about 100 million years ago. Trees evolved broadleaf vascularization. In other words, the angiosperm trees came into being, and that was a phenomenal transformation, because the angiosperm can actually evapotranspire at a rate about 4 times higher than can gymnosperm leaves, needles of pines, and so on. And we now know from the biotic pump how important that evapotranspiration is. But we'll talk about that in a minute. Oops, sorry. I have just showed this particular slide, which comes from Lovelock from some time ago. And I think what I want you to look at is the Earth with life and how much carbon dioxide we have. Well, of course, this is from the 1980s, when we had 0.35% of carbon dioxide in the atmosphere. We're well over 0.04 now, just some 50 years later. And we have 79% nitrogen, 21% oxygen, and so on. Just traces, we have traces of methane. And of course, methane interacts with oxygen. So how come we can have methane in the atmosphere at the same time as there is oxygen? And that is because life has generated it. And the most important things to realize about Venus and Mars is that their atmospheres are full of carbon dioxide, creating a very powerful greenhouse effect, particularly in Venus, which has an atmosphere of about 90 times our current atmosphere. I beg your pardon, yes, 90 times. Whereas Mars has a rather thin atmosphere at 0.07 of our atmospheric pressure here on Earth. And we have the different temperatures observed on the surface, 477 degrees for Venus, 15 degrees for the Earth in general, that's an average, and minus 47 for Mars. I can't conceive of a reason why anybody would want to go and live on Mars. Anyway, we now come to the Earth without life. What would it be like? We would have an atmosphere of 90%, 98% carbon dioxide, just a trace of nitrogen, a trace of oxygen, no methane, very little water, and a pressure 60 times today. And the warming due to the greenhouse effect would be some 240 to 340 degrees centigrade. In other words, it would bake the life out of all of us. Now, this is, for me, a very interesting study which was carried out by P.A. Barrett of New Zealand, of this New Zealand Antarctic Survey. And he has looked back over the last, 100 million years. And in the left-hand part of the diagram, you can see the way the planet has cooled from 80 million years ago, in this case, right the way down to the present here. And the temperature, the average temperature in relation to the temperature today, which we see here, was about 7 degrees higher than we currently are. So the trend has been for cooling to take place. And here we see what happens to carbon dioxide in this right-hand part of the diagram here. It goes from up some 2,000 parts per million right the way down to now, when it's about 400 parts per million. And if we come to this next slide here, which goes back to 100 million years, we can see what's happening. We're going down like this, the trend here, and then now we're shooting up to back towards what it was 100 million years ago. Now, what has brought about this cooling? I suggest that it is because of the evolution of these angiosperm forests, whether in what is now the tropics or in temperate zone or even in the boreal zone. And those forests have taken carbon dioxide out of the atmosphere and deposited them. And of course, that's where coal comes from, primarily where coal comes from. Now, I mentioned earlier about the fact that this planet has retained its water. We are very fortunate that this part of the atmosphere, the lower atmosphere, that actually there's an inversion of temperature. It's warmer at the surface than it is way up here at the top of the lower atmosphere, which is called the troposphere. Here, it's about minus 50 degrees centigrade. And of course, that means that water, any water vapor in the air will in fact form clouds and condense out. So here we have the cumulonimbus cloud, which has been capped off. And in fact, you can say that the anvil part of the cloud is such in that form because it's so cold up there that the water vapor can't proceed any further upwards. And that is incredibly important for helping the planet retain its water. And I mentioned about ultraviolet and oxygen, and this is just a diagram showing you that water goes into vegetation, vegetation photosynthesizes, that goes to oxygen. Look at this arrow, here we are. That goes to oxygen, and of course, oxygen reacts with UVC to be split into two single atoms, and that can form ozone, and ozone is split by ultraviolet B. And that means that the stratosphere heats up as you go from here at what's called the tropospheric pores, heats up as you go higher up the stratosphere. Now this, I hope, won't be too complicated, but this is part of what Jim Lovelock basically discovered many years ago when he was sailing on HMS Challenger in the Southern Atlantic. And he could measure, he had invented a device which, unlike any device prior to that time, could measure very small trace quantities of gases in the atmosphere. And he could measure a substance which was called dimethyl sulfide. And dimethyl sulfide is emitted from these microscopic organisms, which are called coccolithophores, with their little calcareous shell, very beautiful sculpted shells. And here you can see, well, this is Cornwall. I live right here where the arrow is. I live right there, and you can see these massive blooms of this microscopic algae, a coccolithophore, Huxley. And here you see Ireland, and the southern part of Ireland, you can see a massive bloom here. And this is the Bering Straits between Russia and Alaska. Now, what Lovelock realized was that if the sea surface temperature rises above 8 degrees or so centigrade, then in fact, you get the beginning of a thermal cap forming, which prevents the nutrients from below breaking through to the surface and feeding the algae. And we have here the idea of positive and negative feedbacks. Now, if we go the full circle, and we're going to go around twice, we can see that here is the temperature of the ocean, which let's say is below 8 degrees centigrade. Now, what actually happens if you take these organisms, these coccolithophores, into a laboratory and you give them all the nutrients they want, they actually love a temperature of around about 22 degrees centigrade. So as the temperature goes up, but below a surface temperature, below a surface temperature of 8 degrees, temperature goes up, you get more coccolithophores forming. They generate more of this dimethyl sulfide, and the dimethyl sulfide rapidly oxidizes in the atmosphere and forms what we call condensation nuclei. And they cause clouds to form, which are marine stratus clouds. And these clouds, because various other components are caught up, like dimethyl alpha iodide and so on, these clouds can bring rain to the continents. The clouds, of course, when they form, they reflect away sunlight and they cool the temperature. So the temperature is now lower. That means there are less coccolithophores because their metabolism has been held back a bit. And that means there's less dimethyl sulfide here. That means there are less clouds, warmer temperature, more coccolithophores, and that is a negative feedback. But if the water temperature, surface temperature, rises above 12 degrees, then you get a cap of warm water, which prevents upwellings and prevents the coming up of nutrients like nitrogen and so on. And here we go around the short circle. So if we, sorry, as the Richard arrow come. Oh dear. Oh, I can't see my arrow anymore. Anyway, if you go to the lower cycle, you go from a temperature, which is now, because it's over and above the surface, this is the blue line, the temperature is above the 8 degrees temperature, it's a 12-degree temperature and above. We get less coccolithophores forming. We get less DMS being produced. We have less clouds. We have a warmer temperature. We have less coccolithophores, and that is a positive feedback, with the consequences that the coccolithophores are no longer able to generate clouds sufficiently to keep the surface of the sea cool. Well, we have the Amazon rainforest. I know that Rob showed this diagram yesterday, showing the size of the Amazon in relation to Australia, the United States, and so on. And he made the point that the rainforest acts more like a heart and a pump than it does as lungs, although there is a lung function in the sense that there's an interchange of gases through the process of photosynthesis and transpiration. Now I'm going to move on, and here we see a satellite picture of the Amazon basin with the Rio Negro coming to join the Amazon River. And what you can see is these little minuscule, from satellite imagery, minuscule cloud forming above the rainforest. You can see the way the rainforest is actually actively generating these clouds through its process of evapotranspiration, helped on by cloud condensation nuclei, which the tree releases at the same time as it is transpiring. And what we have is the trade winds coming across between Africa and South America. The trade winds in both hemispheres move from the northern hemisphere. They move in a south west direction and from the southern hemisphere, they will move in a northwest direction. But they meet, which I don't think is coincidental. They meet in what's called the intertropical convergence zone over the Amazon basin. So you have evaporation taking place over the sea. And the evaporation, I must make very clear, is much, much less per square meter of ocean than the evapotranspiration over the rainforest. Probably the evapotranspiration rate over the rainforest is 10 times greater per square meter than the evaporation over the sea surface. Nevertheless, the trade winds are bringing up, are carrying a lot of humidity, which they are transporting straight over the Amazon basin. And here we have the rain, those red arrows, and here we have evapotranspiration taking place. And as Aeneas Salati showed in the late 70s and 80s, that approximately between 50 and 75% of the rainfall is recycled by the process of evapotranspiration. And in fact, you can calculate that if a molecule of water, from the moment it is evaporated and goes up into the surface air, it's carried westwards towards the Andes, and 600 kilometers, during 600 kilometers, the average fallout will be, the average fallout will be 600 kilometers. So you've got perhaps some 5 recyclings over the Amazon basin. And 5 times 600 is about 3,000 kilometers, which indeed is when you go from the coast off Belém in Brazil, all the way to the Andes and to the Paramo. Well, in the case of Colombia, you go to the upper moorlands, which are called Paramos, and then, of course, that rain is also forming the glaciers in the mountain. Biotic pump. It is an absolutely wonderful Gaian mechanism. It's as if life and the forest understands physics, because it's using what we now have come to term classical physics to bring about this flow of air from the ocean carrying water vapor to the continental space, and then enabling that same rainfall through the recycling I've mentioned to get all the way across the rainforest, 3,000 kilometers, and actually produce as much rainfall in the Colombian Amazon, for example, which, by the way, is 100% equatorial, and bringing about as much rainfall, if not more, there in the Colombian Amazon than you actually get at the coast. Okay, so in this graph, and my arrows come back, let's hope. The first thing to realize is that here on the left-hand x-axis, we have the rainfall in millimeters. And the current rainfall is about 2,250 millimeters per year over the Amazon basin. And with the biotic pump in action, the rainfall, even though you're going, as you can see, in the x-axis at the bottom, you're going from the coast at 0 right the way inland, some thousands of kilometers. You can see the rainfall remains intact. Now, conventional models of deforestation, which do not take into account the biotic pump, show that dotted line coming from at the top there, coming straight down to where you get about a 15 to 20% reduction in rainfall. That's the conventional models currently used by the IPCC to denote what happens if you deforest. Now, if we deforest, and let's say we deforest at the coast, we deforest virtually all the way inland, right the way to Colombia, you can see we have this terrible decline. And once we get beyond 2,000 kilometers distance from the ocean, the rainfall in the Colombian Amazon without rainforest would be no more than 0.625% of what it is at the current time. If, on the other hand, you've already deforested at the coast, you've got the dotted line towards the bottom at about 800 millimeters, and then that exponentially declines away, as you can see. And this was from Anastasia Makarieva and Viktor Gorshkov from some years ago. And the y-axis in both instances, the left-hand axis, is actually an exponential log axis. So you go from 50 to 100 to 200, a doubling each time, as you can see, is exponential. And so you can see that rainfall, all those kilometers from the ocean in the left-hand diagram, for the Amazon, for the Congo, and for the Yenisei in Russia, that the rainfall actually increases as you go further and further inland. On the right hand, we see what happens if there's no forests. In other words, the rainfall at the coast falls away exponentially, dramatically. I mean, if we take the case of West Africa, the red line coming down from 1,600 millimeters at the coast, and you track the rainfall all the way inland for practically 2,000 kilometers, you've realized you're in desert, that you're at about 22 millimeters of rain, which is currently what the Negev desert gets in Israel. When Anastasia Makarieva and Viktor Gorshkov came up with their biotic pump theory in 2007, the majority of hydrologists and climatologists said, oh no, this is not the way the world works. Because one thing that Anastasia and Viktor Gorshkov claimed was that the trade winds, which go between Africa and South America, were actually drawn in by this biotic pump. And the biotic pump is, I didn't explain, I think Rob did a bit of an explanation. It works on this in this manner and form, that the transpired water as vapor rises up in the column of air until it reaches cloud forming altitudes, say from 2.5, can be several kilometers up from the surface in the case of the tropical Amazon. Then this water vapor condenses. Now, the extraordinary thing is that if you take just a thimbleful of water and liquid water and you turn it to steam, its volume will increase by more than 1,200 times. It increased by more than 1,200 times. Now, when that same vapor, which is formed from that thimbleful of water, condenses back, it will shrink by 1,200 times. In other words, there'll be an instantaneous implosion. And it's that implosion which gives a big boost to the rising column of air when clouds are forming. And therefore, air is going to be drawn up from the surface to replace the air which is suddenly condensed by a considerable volume, depending, in fact, on how much water vapor has actually condensed. And of course, if air is rising from the surface, it has got to be replaced by air coming from somewhere. And therefore, in the case of the Amazon basin, it's coming from the trade winds. So the trade winds are drawn in by this process of massive cloud forming in the afternoon, for example, over the Amazon rainforest. And remember that the sun is, from our perspective, is passing from east to west over the Amazon basin. So it's like it's a ripple effect. As it passes over the forest, it will cause evapotranspiration. And so you can see how it can be that the forests far to the west are able to draw this air in. Okay, well, there was skepticism initially. And I, actually, at the time I was in Colombia at a university there. And I fortunately had a long cycle ride to get between where I was staying and the university. And in Bogota, there's some wonderful cycleways, and it gave me time to reflect. And I thought up a way to experiment to test the fundamental basis of the biotic pump, the physics, if you like, of the biotic pump. So at home here in Cornwall, I constructed this structure, which consists of a rectangular square donut, if you like, in which I can enclose Cornish air, and the lean-to is the laboratory part of that. And it's about 5 meters high and about 5 meters long, and about the actual structure about a meter wide. And I then experimented by chilling a portion of the air, a small portion of the air inside of that structure. I had a refrigerator outside and copper coils, 2 layers of thin copper coils bearing the refrigerant, if you like. And I wanted to see what happened to the airflow in the structure. I had been told that I would find nothing, that it was a waste of money, a waste of time, and basically I was off my rocker. And I persisted, thank God I did, because what happens was when I switched on the refrigeration, within 30 seconds, I could measure with an anemometer, I could measure a flow of air, beginning from nothing, no flow, switch on, 30 seconds later, the beginning of a flow. And as the condensation rate went up, which I could measure by physics, and I won't go into that because it's a lot of fundamental physics is involved, I found that what you see is the red part of the graph is the rate of condensation. In the case, I used energetic measurements in this case. So this would be the rate, the watt change rate in condensation. The fuzzy blue line is the airflow. And you can see very clearly that the airflow is 100% determined by the rate of condensation. And essentially, that gives proof to what was the biotic pump theory of Anastasia Makarieva and Viktor Gorshkov. And I, as a consequence, I no longer call it a theory, I say it is a principle. Well, here we have the diagram from Anastasia, which in fact Rob showed you yesterday. And what he was really interested in, and Anastasia too, is how much of the latent heat that's carried in the evapotranspired water from the surface where evapotranspiration takes place to the atmosphere, the upper troposphere anyway, how much of that can be irradiated to space. And I think there is very little reason to doubt that 100% of the latent heat that is released as the water vapor condenses, actually goes out to space. That means that the forest is getting cool at the surface because it requires that latent heat energy to bring about the evaporation of the water, like sweat, if you like, which cools us, of course. And at the same time, by this transport mechanism, that same heat that was used is being passed out to space. Yes, and well, this is just some facts which I'll run through very quickly. That the rainfall over the Amazon basin on average is about 2,250 millimeters per year, and the evapotranspiration is more than 50% of that on average at about 1,370 millimeters per year. The solar energy, the sun's energy, which gets down to the surface, which is absorbed by latent heat, assuming that the average energy from the sun is 240 watts, then it will be 41%. In other words, 41% of the sun's energy will be carried out to space if this idea of the latent heat or the air molecule, the water molecules carrying latent heat and then condensing, and then allowing that latent heat to go straight up, radiate straight out to space, if that is correct. Well, I mentioned salinity and that 50 to 70% or maybe 6 times recycling of the evapotranspired water over the entire basin. And again, that if you take the rainfall, the precipitation, and realize that that precipitation means condensation of all that rainfall, then you can determine that about 70% of the heat of the energy of the sun coming in over the Amazon basin, for example, will be passed back out to space. And the implosion energy, as the water vapor condenses and the volume changes by well over 1,000, if I calculate the implosion energy of the rainfall over the Amazon, believe it or not, it's equivalent to about 780 atomic bombs going off every second over the Brazilian Amazon, which actually means about 65 watts per square meter. And I've calculated that watts is absolutely sufficient to explain the airflow of the trade winds. In other words, that there is sufficient cloud forming taking place over the Amazon basin to justify what Anastasia Makarieva and Viktor Gorshkov had stated, that the trade winds were, if you like, sucked in by this process. Well, this is in the Upper Putumayo, in Colombia. In the far distance, we're looking towards Ecuador. And here you can see these clouds being brought right over the Andes, direct from the Amazon, and bringing rainfall and creating that lake. Now, there's a big question mark. Does this biotic pump process mean that we must not allow any clearings to take place over the Amazon basin if we want to protect, if you like, the rainforest, and if we want to cool the earth in some manner or form by this transport of latent heat? Well, in the upper diagram, you can see rainforest and a clearing. And in fact, the clearing, which is relatively small, means that it actually enhances the rate at which water vapor passes into the atmosphere and forms clouds. It can be advantageous to have judiciously correct size, smallish clearings, and you could have agroforestry, you could have the indigenous gardens, the chacras as they're called in Colombia, and so on. But if you make the clearings too large, then the opposite happens, and the forest begins to die away. It can't provide the humidity, it's sucked dry, if you like. So I think this has to be taken very carefully into account in our regeneration efforts. Now, this comes from a hydrologist, or two hydrologists, well known, and this was actually before the biotic pump idea had been published. And here they show something which I think is intriguing at the time, that you have the relative precipitation in the y-axis, and you have deforestation taking place. And you can see from the red line that if you deforest a bit, you actually get enhanced rainfall, which may make you think, oh, well, this is fine. We can deforest and we get more rainfall. But then you pass the critical point and there's collapse. And that's basically what that diagram is showing. I pointed out here on the right-hand side, they had not taken the biotic pump into account, because if they did do, then 100% deforestation would mean a relative precipitation from the central Amazon to the Andes of 0.01 and close to zero. And of course, this shows you exactly what the implosion force is like. Somebody had cleaned out this vehicle, this tanker, with steam, and they stupidly then closed the valve into the tanker, or closed the tap, if you like, and left it. And of course, atmospheric pressure was sufficient to cause that. So the implosion energy that I describe and I calculated from my experiments is absolutely a force to be reckoned with. And it's a force which the rainforest 100% makes use of in order to draw in winds like the trade winds, surface winds. Well, if the biotic pump falters, we're going to have grave problems, because the southern part of South America receives 70% of its rain courtesy of the aerial river, the atmospheric river that we see depicted here. There's also a connection that same atmospheric river passes down south, provides 70% of southern Brazil's rain, a good 50% of Argentina's rain, on which they depend for their agriculture. And then it passes across the Atlantic, and some 6 months later actually gets to South Africa. So South Africa actually, for its rainfall, depends on a vital Amazon basin. There's also a connection going from that same airflow, which is called a teleconnection, to the Midwest of the United States. And the Midwest gets its rain courtesy of the Amazon basin just towards the end of spring, when, of course, the crops that have been sown need the rainfall in order to initiate their growth and mature into viable crops. So the Amazon basin is critically important from that point of view for the entire planet. Well, this is my calculations. I don't expect you to read them in detail, but what I wanted to show here effectively with numbers was that we can see that NASA is overheating the NASA, not NASA's overheating, that NASA has calculated the overheating of over the Earth's surface per year by that gigantic amount of watts, 2.6, etc., times 10 to the 22. If all the latent heat of the Brazilian Amazon, that's 5.2 million square kilometers, was irradiated to space, the cooling effect would be exactly equivalent. In other words, if we wanted to get rid of the heating in toto, we would need to find and regenerate and reforest about 5.2 million square kilometers of tropical rainforest. But I would suggest that any reforestation project of a goodly size will in fact help to bring down the global temperature, the surface warming. And as we heard from Jim Garrison earlier, we need to work extremely fast to bring this about. We absolutely, we don't have time. And the warning that we might get a temperature of in excess of pre-industrial levels of 1.5 degrees centigrade is very disturbing indeed. Okay, and well, that in essence is my talk. What I have not mentioned in particular, I think Rob did mention it yesterday, was that if you have good forests and they are they have a viable biotic pump going, they are drawing in air from the ocean on a kind of constant basis, like a breathing in, not a vicious movement, but a sucking in, as you would as if you were breathing. And this helps cool the ocean because the airflow will cause more evaporation to take place, help cool the surface of the ocean. It will take the sting, if you like, out of ocean warming to an extent that it will have an impact on hurricanes, typhoons, and storms, and with their sea surges. It will have an effect which actually will calm the entire weather system. Forests, in fact, are 100% a calming influence. And if there are winds, strong winds, well, of course, the forests tend to break up those surface winds. So they act as windbreaks in that respect as well. So the forests too, if we are planting, regenerating forests, will take carbon dioxide out of the atmosphere. So we have a double wonderful, a double whammy, a wonderful effect of cooling and reducing greenhouse gases. It's the way forward. It absolutely is. And I mean, I think governments through the IPCC and so on are beginning to become aware of the importance of forests. But we need not just to realize their importance, we need actually to act right now. So thank you very much. Right, stop. Okay. And
thank you so much, Peter. I think Rob's going to join us as well.
yes.
You know, I'm just sitting here, just taking in the enormity of the biotic pump that I hadn't heard very much about before I met Rob, and the way you laid it out in terms of the intricacy of how it all works
Yes.
is quite astonishing. And
Yes.
thank you for all your research that you've been doing all these years beavering away with your slide rule and calculator. It must be
Yes.
amazing.
I just want to add that actually the physics that climatologists use and the physics which I employed in my experiment are the same. And the physics tells you you have to have a biotic pump. So why anyone should deny its existence of at least any climatologist is beyond me, because there it is in plain writing. The physics tells you, and of course, trees understand it.
Yeah, exactly. Well, I have some questions, but Rob, do you want to make any comment or direct the conversation in any way?
I'd love to hear your questions, but basically I have one particular one, Peter. So you've shown the importance of the biotic pump. We all know that trees cool, but large forests move these amount of atmospheric moisture over the planet, basically irrigating the inlands of lands. So what would be strategically the best way to regenerate the planet so that we can actually get more moisture in land and avert basically what is happening now? Is sort of a desertification of part and drying out of parts of the world. Thank you.
Yes. Well, the first thing to note is that if deforestation takes place mainly at the coast, then that is where you have the most impact on the biotic pump. The rate of reduction in the biotic pump and in its functioning will be if you deforest towards the coast. So the first thing to work on is not necessarily try and grow a forest inland when indeed all the way to the coast is being deforested, because your inland forest, particularly if it's more than 100 kilometers away from the coast, actually probably may in fact dry out, and it may have a counter effect in causing a drying out rather than a warming. So one needs in fact to put one's focus and emphasis, in my opinion, close to the coast and regenerate. For example, the southern part of the Amazon in Brazil, there's been, and the Mata Atlântica, Atlantica, as you were talking about yesterday, those forests really, or where it's been deforested, one needs to get back to the coastline and reforest there primarily, and then work one's way inland. I think the challenge is to know what, once you start getting a functioning forest, what size should the clearings be for, say, agroforestry and so on. I think this is something which, will need some reflection, because if you make a clearing too big and you reduce significantly the biotic pump process there, that will have a negative effect in as much as it will tend to dry the forest out rather than in fact enhance rainfall.
Thank you. Jim, you want to?
Yeah, I would like to, in the little bit of time that we have left, Peter, I would like to go back to James Lovelock and Lynn Margolis and their profound insight that Gaia, the planetary ecology, was in some sense a conscious living organism. Because I think that was the Copernican shift that they introduced with the Gaia hypothesis and the Gaia theory. So I think all of us would just love to hear, since you were there sort of at creation with them and knew them and followed them, how from a scientific point of view, do you understand Earth ecology as a consciously intentional living organism. What does that actually mean?
Wow, it's a very good question. I think Jim would always emphasize that the Earth as a whole, with all life, is a kind of superorganism rather than organism. And what he meant by super, I believe, was rather like, I mean, he would describe a tree with its wood and bark and so on, and point out that the inner part of the tree, in fact, is virtually dead. It's dead wood in a sense, but of course the living part is in the bark and the xylem and phloem and so on. And so he, I mean, I think he would not have thought of the Earth itself as if the Earth were, the rocks and things were kind of necessarily animate, but the relationship between the rocks, the ocean, the surface in general, and would be a totally 100% part of a living process. And I rather, I think, go along with that, that notion. I think that I see Gaia as sort of, Gaia is always striving to come into being. In other words, life has time to evolve, and then there's some major catastrophe, which, whether it's an asteroid or whether it was the Permian, apparently with massive volcanism taking place across the continents, which, you know, at that time managed to eliminate, I think, perhaps 3/4 of all life and the different species. So life given left to its own devices, so the biosphere left to its own devices will gradually move towards the perfect state of Gaia. Of course, it's always striving to get there, and through these negative and positive interactions or feedbacks. And I think that, you know, post the dinosaur time, that's basically what's happened. There was, you know, I mean, the asteroid catastrophe, but of course that gave us the opportunity to emerge from the raspids and the primitive mammalians and so on to you know, generate different forms of life, very different forms of life. I mean, one thing which intrigues me is that the dinosaurs in their heyday were around when the surface temperatures were, as I say, a good 7 degrees warmer than pre-industrial times. And that's when these forests were beginning to flourish. And the continents are kind of formed as we now have them, or in the process of forming as we now have them. And I just wonder whether that was a time when, in fact, if we were around then, when there would have been extreme events, climatic events happening all the time because of the greenhouse effect of that time. And of course, so I see the time passed since the dinosaurs, when these forests were flourishing, such that we got our first, I think Antarctica first began forming permanent ice about 18 million years ago, and then the Arctic Circle some 3 million years ago. So one sees that the forest was so important in bringing the temperature down, in smoothing out these potential for extreme events. And we emerged at a time of extraordinary climate stability. And Lovelock always stated that the fact that when the Earth has ice and, you know, is going from ice age back interglacials and back again and so on, it's healthy because there's this temperature buffering going on all the time, whether the ice, of course, reflecting away sunlight and so on, as we know. So we are moving, we are moving back to the 100 million years back in terms of putting carbon dioxide back, burning what the forest laid down over 100 billion years, and destroying the forests at the same time. So we really are 100% shooting ourselves in the foot.
Yeah. Coming from a scientist to say we're 100% shooting ourselves in the foot. That's a very strong statement, sir.
Well, it is. But sadly, it's the truth.
Yeah.
You know, and I think, yes, and I think, I don't know whether Jim, because he died last year at the age of 103, as you know, I don't know how much he took on board the biotic pump, because I see the biotic pump as one of the prize Gaian examples that we have.
Yeah. Well, let me ask you just to comment on what Rob said yesterday. Rob, I was struck yesterday in your comments where you were just saying, given the situation, we're up at the ceiling of 1.5 threshold. We've got CO2, we've got the Amazon being devastated, that the one thing that humanity could do would be everywhere around the world increase biodiversity and biohealth of the planet in a regenerative way. And I thought that was really actually quite simple, but also profound, that rather than looking at one specific thing to do, that
yes,
what humanity needs to do is just increase biodiversity at every level, everywhere
yes,
that we can, as the quickest, most effective solution to our predicament. And Peter, I just given everything would you agree with that? And
I would.
Whatever comment you want to make.
Yeah, I undoubtedly would. I would. And I see, here, and I think in the States and elsewhere in Europe, we have these rewilding projects which are going on. And some of my friends are very much engaged physically in rewilding tracts of land. And it all adds up. I think we're I think we agriculture is, as Rob was talking about, is so it's so essential to have a very good look at agriculture, because when I came to Cornwall 50 years ago, it was still, dare I use the word, relatively primitive here. I had no electricity, I had no running water, just 50 years ago in England. And I've seen, and the farms round about me were very traditional. And the idea was you only had as many cattle, cows, dairy cows on your land as you could feed from your land. In other words, you had to be self-sufficient. And that all changed dramatically. Part of the Industrial Revolution, part of the way in which post-war, or even during World War II, the government insisted that everyone use chemicals to increase so-called fertility. Of course, actually, it's counter to fertility, as we know, and so on. And so we've only, in a sense, in many parts of the world, we need go back no further than 50 years to an agricultural system which was supposedly self-sustaining.
Yes.
And I remember I was brought up, I was born before World War II, and I remember that we had chicken once a year at Christmas. You don't that was You know, I mean, that was fantastic. We got chicken for Christmas, and for once a year, and you know, everything was rationed and so on. But we were actually, people were healthier.
Yes.
They realized that white bread, you know, was actually unhealthy, and so you had to produce bread which had a certain proportion anyway of wholemeal flour, and so on. So the war actually caused a really good look at nutrition to enable the population to survive. Yes, we did depend on the United States to bring us food, which was when all that shipping was indeed blasted out of the water. But I think we need the efforts on the land, rewilding and so on, regeneration. But every one of us actually we need to cut back, to think back, and to a much more healthy time. You know, well, I mean, there's a lot of questions being there, but that's a very simple
Peter,
answer. Yeah.
Well, thank you
Peter,
so much.
Can I just
Rob.
intercede for 1 second? That
Yes.
I think 2 weeks ago there was an article coming out that showed that in Europe, if we would all go circular, we would actually need only 30% of the land that is used for agriculture right now. It's a series of measures, but basically, if you apply that to the whole world, you could basically say that we have enough land to rewild if we reorganize our food production in the right way, and with that we can increase the tree growth and basically cool the planet and calm the weather. It's absolutely possible, but we're running out of time.
We are. Yes.
That's why Andrew Bailey just put in the chat that maybe under current world circumstances, we should change our name from Homo sapiens to Homo stupidus.
Yes. Well, Teddy Goldsmith's friend, Athol, he would not talk about Homo sapiens. He talked about Homo rapens.
Say more.
Rapens, man the violator.
Yeah, rapen. Yeah, man the violator. Yeah.
The raper. I mean, I don't know.
Yeah.
Not reaper, but raper.
Yeah. Well, Peter, thank you so much for your just presence and your indefatigable energy that you've just kept on for all these years, expanding the Gaia hypothesis, now a theory. And it's been so powerful, the work that you and Lovelock and Margolis did, because I think it confirmed the most ancient awareness of humanity about who we are in relationship to the larger ecosystem. You know, that we're part of a living organism, and that living organism is not only exquisitely intelligent, but because of that has a capacity to continue to complexify and support higher and higher levels of life in a completely natural and organic way. And that's how come we got here. And so I just want to thank you on behalf of our global audience for the work that you've done. And I felt very privileged today to be able to bear witness to this a deep scientific awareness and your compassionate heart for our earth and for humankind. So I just want to thank you for all that you've done.
And thank you too, and everyone else, and thank you for listening. And I love what you're about. I mean, I think that's absolutely an incredible initiative, and so I'm grateful to Rob for bringing me back into the world that I enjoy, with people that I really respect and enjoy listening to.
Yeah, well, we'll have to have you back down the trail.
Okay, well, I look forward to it.
Rob, do you want to close us out and then just say a word about tomorrow?
Yes, thank you. And thank you, Peter. So it's always wonderful to hear you, and I'm very privileged to know you. as I am actually also to know Jim. So tomorrow we have the third part of cooling climate chaos, a practical path out of the Polycrisis. And basically, a couple of people will present. We don't know exactly for sure if it's going to be 2 or 3. We'll see what happens. But the first one will be Peter Bruce Erie, who actually will do a presentation from New Zealand, and will get up at 3 a.m. to do so. And he is the author of How Plants Cool the Planet. So obviously completely up our alley. And Peter will show some practical applications that are more on the ground. We have been talking about planetary level basically, but in the end, the work and the action needs to happen on the ground everywhere by everyone. So I think I'll leave it at that, and I hope some of you will have the time to come in tomorrow morning, again. Thank you.
Thank you, Rob. Thank you, Peter. That'll do it for us for today, everyone. We've had a magnificent session on the biotic pump, which is key to planetary ecological equilibrium. The biotic pump. You're all welcome to the after session chat. You'll see the link in the chat box. And then we'll see everyone again tomorrow for our third and final day on how we can cool our climate chaos.